Hello, good morning, everyone.
Good morning.
I'm super excited about this. While you guys are getting in, I'm actually interested in because we have a good variety of countries here. So, can you put in chat maybe like what country do you come from? I would like to see that. Would that be possible?
Here we go,
Belgium.
Belgium.
Okay, Ireland, France. Nice. Look at that, the variety. This is amazing. We even have people from South Africa. Let's get it started. So, just a few housekeeping items. Keep your microphones on mute during all presentations, please. Feel free to ask your questions in chat, and you will not interrupt the speaker, but we may use them for a live Q&A at the end. Please practice careful communication, as this webinar will be recorded as well and made available on the Bridge BS YouTube channel, Crowd Helix platform, and the Preserve Horizon 2020 website. The incredible potential and opportunities around bioplastic recycling. The Preserve Horizon 2020 consortium is developing a range of packaging items that are 100% based on renewable resources, promoting minimal environmental impact, encouraging recycling, and promoting circular economy. The goal is to replace 60% of the fossil plastic food and drink packaging by 2030, fostering sustainability and economic growth. Outcomes of this webinar will be shared with the European decision makers and institutions aiming to influence future policies on bio-based packaging, recycling, and upcycling. Let's get to our first speaker. I'm really delighted to have Christina Eisenberger introduce the Preserve project because that's what she's going to do. Christina is a research group leader at the Sustainable Packaging Institute of Alpstad Sigmaringen University with a doctorate in food microbiology. She is actively participating in several multinational research projects in Preserve. She acts as scientific and technical coordinator. Christina, over to you.
I'm on mute again. Hello, everybody. Thank you for this nice introduction. I will quickly share my presentation. I hope you can see it now. Okay. So, thank you, everybody, for joining. I will now introduce you to the Preserve project with the long title, High Performance, Sustainable Bio-Based Packaging with Tailored End-of-Life and Upcycled Secondary Use. So we start with some general figures. Yeah. So it's a 4-year project. We started in January 2021, which means it will end by December this year. We are 23 partners, including 7 research organizations, as well as partners along the circular supply and value chain with large end users and, of course, the largest bioplastic producers users association. And as you can see in this graphic here, our circular value chain from raw materials to plastic packaging converters, end users, and up and recyclers. And we have 3 industrial partners at least for each of these sectors. So I think it's safe to say that we represent the circular value chain within our project. But why is Preserve needed? So in 2021, 90 million tons of packaging were produced, which already shows us that Europe is so far from its sustainability goals, such as carbon neutrality by 2050 and to have all packaging recyclable by 2030. And having all these packaging recyclable by 2030 goes hand in hand with a required recycling rate of 70% by 2030. In 2021, which were the most recent numbers I could find, the recycling rates in the European member states varied from 38 to 80%, with an average of 64%. So 80% sounds really, really good, 38% not so good. And of course, the aim is that the recycling rate in all member states is around this 70%. And also it should be noted that this 64% includes all type of packaging. So it includes fiber-based packaging, which has a very, very good recycling rate. It includes glass and metal, which also have good recycling rates. And if we only look at packaging, plastic packaging, we are not even talking about 40% recycling rate. So we need high-performance bio-based materials to be developed and produced. And of course, for them to make an impact, their recycling approaches need to be better established and in motion to be able to adapt. And depending on the biopolymers application and expansion of the biodegradability to more environments should be considered. So what are our objectives? So in Preserve, we start with new biopolymer synthesis, from which we produce packaging. But of course, we not only produce packaging, we have the so-called, or I call it like that, the bioplastic upgrading and upcycling toolbox. And within these toolbox, we, for instance, have protein barrier coatings and adhesives, PHA coatings, e-beam treatment, and enzymation. And we use different combinations of these tools to produce packaging, which is then used for primarily for food and packaging, for food and beverage packaging. And at the end of life, we have several options depending on the material we use. So we could go in some applications for biodegradation, which results in biomass that can be used as a new feedstock for biopolymer synthesis. Or we aim for material recovery. There we also have several possibilities. We can go for enzymatic recycling, of course, depending on the material we use, which results in oligomers. So we break down the polymer into oligomers, and that can then again be used, for instance, for new biopolymer synthesis. Or we go for self-reinforcement of bicomponent biopolymers and delamination for recycling. So we're building multi-layers that can then be recycled with the tools we use, which leads to recycled biopolymers, which can then enter again the bioplastic upgrading and upcycling toolbox to produce, for instance, personal care packaging or textiles and composites. In former webinars, we focused on, for instance, the coatings. This time, my colleagues will talk more about the recycling. And the take-home message from overall Preserve project is that within the project, we have the potential for bio-based multi-layers to rethink food packaging. So we can go from flow packs, trays, pouches, and beverage bricks, use them design them in a bio-based way in a way to separate them, so that they can really separate these multi-layers and recycle the components for a secondary application in high performance fields, such as personal care and transport packaging. So going from flow packs, trays, pouches, beverage bricks to injected jars, bottles, carrier boxes, and bags. And with this, I'm already at the end of my presentation. I would like to thank you for your attention. And I would also like to draw your attention to these QR codes, because within this project, we do quite some surveys on consumer perception, social life cycle assessment, and therefore I would like you to scan these QR codes, save them for later, and participate in our surveys. And for the consumer perception, I may note that we have it available in 7 different languages, so it should be easy to participate. Thank you.
Thank you so much, Christina, for this very informative presentation. So up next, we have Nicola Fortunati, who recently graduated in chemical engineering at the University of Pisa. Nicola works as R&D engineer with Planet Bioplastics, with strong orientation towards sustainable development and innovation in polymer chemistry. His skills include the design, synthesis of sustainable polymers with a focus on renewable raw materials and eco-compatible processes. Nicola will talk about delamination of multi-layers for recycling. Nicola, the screen is yours.
Good morning, everyone. My name is Nicola Fortunati, and I'm a researcher and developer engineer who following the project, Preserve project. Before I start, I would like to make a small introduction to Planet Bioplastic. Planet Bioplastic is an innovative startup spin-off of the University of Pisa, born in July 2017, for the entrepreneurial idea of 6 partners, 2 university professors with long-standing research experience in the field of biopolymers, a commercial expert specialized in the sector, and 3 businessmen owners of a company that carried out recycling and compounding of plastic material. The company was founded with the aim to developing biopolymers compound for packaging and technical sector. The principal idea is to meet the consumer requirement and shortening the distance between the academic research and the small medium size company. Planet has a well-equipped laboratory to do mechanical, thermal characterization, and secondary processing tests, and the ability to do extrusion from the laboratory level to pilot scale to industrial production. As we said by my previous colleague, the main aim of the Preserve project is to maximize the recycling of packaging. Today, in food packaging, the most commonly used material are polymer-based material, commonly used to combine the respective performance of different polymer to provide a range of property cannot be obtained from the monolayer film. Choose one the most important use that the products of the is low recyclability, and Preserve multi-layer film using bio-based coating and adhesive have been developed as shown in the figure. Planet in Preserve has 2 tasks. The first is to optimize the condition of the lamination process, which will result in the separation of multi-layers, enable to the separation of the different layers of multi-layer material and make their recycling more efficient and sustainable. In the second task is the implementation of pilot plant in which the delamination process of different material developed in the project can take place. In the first part of the work, initial screening of different commercial soap and substance such as saline soap, enzymatic soap, and alkaline solution was carried out to assess which are the most effective in removing the VPE. In order to select the best combination of solvent and process condition. As we can see in the table in the figure, the substance that gave the best result were the sodium hydroxide solution and enzymatic soap extrazine plus LH. In the next phase, the selected soap were used in different substrates, both plastic and paper, in order to test their effectiveness in the removing the protein. It was seen that the removal of polymeric substrates is more easier than the remove in paper substrates. In the third phase, the effectiveness of selected soap was evaluated on multi-layer structure made of different polymer and paper in order to verify if the process could be used in the final structure of the project demonstrator. And some of the demonstrator facilities for Preserve will be accessible in the first phase. The process was scaled up in order to identify and develop the optimal process condition. And this phase, the optimal solution material ratio was seen, and is analyzed how often a solution could be used. In such a way, it is possible to minimize the use of water and soap. And in image, it shows the material of metallized PLA multi-layer film before and after the washing process. And we can see how the metallization and the various film layer has been separated, making the material ready to be recycled and used in new application to reducing the environmental impact. In the second task is referred to the develop of pilot plant in which the delamination process of the different material developed in the project can take place. The plant is developed by Planet and can be divided in 4 blocks. The pre-treatment in this phase is necessary to make the material processable and transportable and include the grinding and the pre-washing. In the first process, the material must undergo in grinding to reduce the dimension of the plastic and this make the material once ground, the material is washed to remove once residue with which the material has previously come into contact. The core of the process is the delamination, and in this part, the material is delaminated and we obtain the individual layer of the material. And the other part is the separation, and this part is involved both the separation of the various layers of polymer and the separation of dirt from the washing solution. The separation of the solution, the material is carried out with a vibrating screen, and the separation of this, the separated solution is collected in a tank and recirculated in the delamination tank so we can use this for several washing during the reducing the consumption of water, soap, and energy. And for example, if the multi-layer are made by polymer with different densities, such as PA and PAT, it's possible to separate them with the flow-seek separation system. And the finished step is the drying and pelletization that include the drying of the material to remove the water and the pelletization to obtain a new material that is possible to use for another application. Thanks for attention.
Thank you so much, Nicolo, for your insights about the delamination and the results on how that is done within Preserve. Amazing. I'd like to get to our next speaker, Robert de Bisschop, getting ready for his presentation. Rob is going to give the third talk and the second speaker for advancements and results of the Preserve Horizon 2020. Robert de Bisschop, plastics characterization, processing, and recycling researcher at Centex Bell. Robbe has been a researcher at Centex Bell for 3 years, working on different European projects geared towards polymer characterization, bio-based polymers, and polymer recycling. Robbe will talk about potential of using self and microfibrillated technologies for mechanical processing of biopolymers. In the meantime, while Robbe has his title slide, I'm asking the CrowdHelix team if my sound has been improved, because I did change my setup. Just let me know, because it's all about your experience.
Yes, perfect.
Thank you so much, Robbe. Without further ado, over to you. Enjoy.
Thank you very much, Peter, and good morning, everyone. So, like Peter said, I will be talking about 2 separate things in the Preserve project regarding the mechanical reprocessing of the biopolymers, and it's actually 2 different techniques. But first of all, before I start with my presentation, I will talk a little bit about Centex Bell, explain what we are, what we do. So Centex Bell is a collective research and technical center in Belgium, and we are mainly focused on both textiles and plastics. And we have 3 different sites in Belgium. So on one hand, in Ghent, our biggest site, we do a lot of textile testing. So there's in different laboratories, we do physical, chemical, fire testing, etc. And in Grasse-Logne, we have a big laboratory that is focused on microbiological testing. And then the site where I am at in Kortrijk, we do most of the pilot extrusion platform. So also what we will be using here in the Preserve project in this presentation I will be talking about is actually the extrusion of both the textile and plastics. So first of all, I will just talk a little bit about where is my presentation, where are these techniques used inside of the Preserve project. So Christina has already talked a little bit about the whole Preserve project. So mainly what I will be doing in Preserve project, we have two different types of demonstrators, like Christina mentioned. We have the bio-based and recyclable food packaging. And then these materials from this packaging will then be reused into recycled personal care and transport packaging. And it's actually the reusing of these materials in the different techniques that we will be using these two techniques to reuse this in these type of demonstrators. So first of all, a highlight a bit about the activity. So both of the technologies to situate them into the project and also in which materials we have. So here you can see the three demonstrators, the food demonstrators on the right. And these materials are, on the one hand, PLA based, and on the other hand, they are multi-layer materials from polyethylene and also PET or polyamide to get the barrier properties. And we will be using these materials to actually form, on the one hand, with the PLA, the self-reinforced materials. And then on the other hand, with the multi-layer materials, we actually use the multi-fibrillated materials, microfibrillated materials, sorry, with polyethylene being the matrix, and then using this PET or PA material that is very strong as actually a fibrillated dispersed phase inside of this polyethylene. We will be using this via cast film extrusion, so all of these results are done via cast film extrusion. Also, some trials have been done using filament extrusion, but I will be talking on this cast film extrusion process. Here in this small video, you can see our cast film extruder, the pilot extruder that we have at Centexbel. We can use either a very small die with one extruder or a multi-layer larger die with 3 different extruders. It's only a pilot pen, so it's on a semi-industrial scale, but not just on a very small lab scale, just to let you know. And then there are 2 things that I will also be talking about, not in this presentation, but I just want to mention them as well, because there are very interesting results also from the Preserve project. One of them is actually using enzymes into the PLA, and using these ones will actually create a very good biodegradable PLA that is much faster biodegradable. You can see here we have I will look at a pointer, so my laser pointer, we have this graph, which is the light green one, which is the reference PLA, just a standard PLA. And when we actually add 5% of enzymes, you can see that the depolymerization is actually already very fast, very broad. And we will try to get to home composting condition. Still research is ongoing at OWS to look at the really biodegradation results. But as they take a lot of time, we are still working on them. But I just wanted to mention this. And then on the other hand as well, E-beam treatment, which is done by ASU, which is actually to upgrade the barrier properties of these materials, of the multi-layer materials that we use, the microfibrillated materials now, so to upgrade actually the properties. I won't be mentioning these further in the presentation, and mainly just focus on these microfibrillated and self-reinforced materials. So first of all, the microfibrillated materials. And this is actually an overview of how this is going. So we have the matrix phase, the polyethylene, and then the dispersed phase. After compounding, we will get this morphology. So if you look very closely with a SEM microscope on this, you will see a drop-shaped morphology of these materials. And what we try to do is actually via cast film extrusion to create fibrils of these droplets, so stretch these droplets out so they make very strong fibrils that are connected to the matrix by using compatibilizers to upgrade these materials. So first of all, what do we look at? How do we create this? Well, first of all, the viscosity of these materials that we start with, the polyethylene and the PET or the polyamide, is very important to connect with each other. Then the compounding is very important. You see this drop shaped. Of course, this can change. You can go very fast, you can slower. The viscosity will depend on this as well. The temperature will also have an influence. Next of all is the compatibilization. We will add this during compounding a compatibilizer, and this is mainly to add the adhesion between the two phases. So these fibrils are really connected to the matrix, giving their strength to the material. Then next is the extrusion temperature. Talked a little bit about this as well during compounding, but also during the extrusion. The temperature where we will be using these, as the polyethylene and the PET are having a very different melting temperature, will be very important during the process. And then last of all, just the cast film extrusion, the roll temperature, the speed, the stretching during the extrusion is also very important to create these fibrils. And here I wanted to show you a graph of how this looks using different viscosities and also draw ratio, so how much you stretch the material during extrusion. We are using cast film extrusion, so we have a very low draw ratio, nothing compared to filament extrusion. But it is also notable that when you have to create during compounding already some fibrils that are pretty good, that you don't have to stretch much, and that you get after drawing at just a cast film extrusion, that you get nice fibrils. If you do this, the same process on, let's say, filament extrusion, you will already have some fibrils during compounding, maybe, and then also you use a very high draw ratio, you can actually break these fibrils up so they have a decreased ability to improve the properties of these materials. So depending on how you will do this, process these materials, this will depend. I wanted to show you here as well different viscosities. So how much can a viscosity actually change when you use different materials? So we have done this analysis with virgin materials. You can see the different grades here. And on the right, we look at the viscosity ratio. So the viscosity of your dispersed phase divided by your viscosity of your matrix phase. And then you can see, so the yellow graph is the PET, a polyclear, so a version, a grade of the PET dispersed in the bio-based LDPE. And then the blue graph is another PET, and the red graph is also another PET. If we look at cast film extrusion, we look around a shear rate of 100. If you look at this, you can have a viscosity ratio of 0.4, but also a viscosity ratio of 0.8. Again, this will differ from the shear rate. So depending on your extrusion process, this will be different, but also using just the different grade, you can have a very large viscosity ratio. So we look at these different ones to look at how do we create these fibrils. And here I can show you two SEM images of a microfibrillated reinforced material. On the left-hand side, we have the cross-section. So on the cross-section, we see, well, all these little droplets that are very good dispersed into the material and good divided into the material. And then we look at the longitudinal section, so the extrusion, on the extrusion direction of the extrusion process, there we can see that we have very nice, good-looking fibrils of this material. We can also see this into the mechanical properties. So if you look at, do we get an improved strength into this material? On the left-hand side, you can see a reference LDPE without any fibrils attached. And then you can see with polyamide, we do get some improvement. Notably also is a very big improvement, and if you look at these results here, is with adding a compatibilizer. So really looking that the matrix and the fibrils are bonded together, so you get this strength increase. And you can see when you look at the orange bar that you almost double this by using these compatibilizers. And also, a compatibilizer will very much increase the processability of your process. Then I go over to the self-reinforced materials. So we look at PLA, two different types of PLA that you combine together. You have an amorphous PLA, the LX175 here, and then a semi-crystalline PLA being here, the L175. And you actually use this together in a multi-layer film. We have used two different thicknesses of films, one 50 microns that is more for the packaging side, but also a 300 micron one that is used actually for thermoforming. And this is very important as well. When I go over to the next slide here, you can see at Südpack, they have thermoformed these PLA sheets into very small cavities of 1 centimeter. And this is very important to show, because when you try to thermoform semi-crystalline PLA, it is very, very difficult because of this crystallinity. When you try to heat it up and then try to create these cavities, try to thermoform, it will break, especially during the edges of the material. But using the self-reinforced PLA film, you can actually very easily thermoform this while also having a very high strength, comparable or more towards the semi-crystalline one, because that is the difference. When you use a semi-crystalline PLA grade, you will have a higher strength of the material. Then the last slide I wanted to show is not something that is used with these fibrillated materials or the self-reinforced PLA material, but is actually just a recycled PLA material. This is done by multifilament extrusion, and then by creating a non-woven. This is a hybrid non-woven with Denim X. So this is a company also into the Preserve Consortium, and they use their denim fibers together with these RPLA fibers to create a hybrid non-woven. And then after this, this non-woven will also be finished with a microplastic reducing coating to reduce the microplastic release, and then create this kind of carrier box. So this is after thermoforming as well, with recycled PLA material. So thank you all for your attention. This was my presentation. If there are any questions, feel free to ask them also in chat. Timing wise, I think also in chat, I will try to answer your questions as good as possible.
Thank you so much, Robbie. This was so insightful. And guys, isn't this amazing? Just look about the last one, for example. You know, we're talking about recycling PLA materials and then recycle the nonwovens and then get that back and thermoform them again. And then you see that what was shown on the screen. I think this is amazing. So proud to work with these guys in this project. But anyhow, I want to get to our next speaker. So thank you very much, Robbie. And I'd like to draw attention on what he just mentioned. We saw a great question coming in, but I can imagine that you also have questions. So please put them in chat. Our speakers may answer them in chat, or we'll discuss them later on. So now I would like to introduce Estela Lopez Hermoso, EU Project Manager with European Bioplastics. Estela is a EU Public Affairs expert who holds a master's in European interdisciplinary studies. She connects stakeholders and aligns research with policies like Cohesion, Interact, Horizon 2020, and Bioplastics. At European Bioplastics, she manages dissemination, training, communication, and the Preserve 2030 roadmap. Estela will engage with you through several questions where she needs your help, so be ready for that. And Estela will talk about Sustainable Circular Bio-Based Packaging Roadmap 2030. Estela, the screen is yours.
Thank you, Peter. Thank you very much. I'm going to share my screen. Great, thank you. So thank you, Peter, for the introduction. Thank you very much for inviting me here, my colleagues, Crowd Helix, who's organizing the event. Peter, you're doing great. We have already worked together in this kind of setting, so I'm really glad to be here. Since I was introduced already, let's just get to the point of my presentation. So today, as Peter mentioned, I will talk about our Preserve Roadmap 2030. This is the outline of what I'll be talking about. So what is this roadmap 2030? Then what is the current status of this roadmap? We launched a co-design process, and so I'll talk about it, but especially about the input gathered from stakeholders and the input that I want to gather as well today. I'll take any opportunity to gather input. And then about how do we take the roadmap to the next level? What's happening then next? Then a few words, of course, about European Bioplastics. For those who are not familiar with us, we are an association representing the interests of the bioplastics industry in Europe. We were founded in Germany in 1993 as, I'll pronounce the acronym in German, but we are based in Berlin and we have a liaison office in Brussels. We represent right now over 85 members throughout the European Union, but also beyond. And we serve as a knowledge base and business network for companies, experts, and all relevant stakeholders engaged in the development, production, application of bioplastics. So what do we do? So our main mission is to raise awareness and inform various audiences about the benefits, potentials of bioplastic for a sustainable economy and society. We closely monitor, evaluate, and contribute to relevant developments in EU legislation. And we provide comprehensive information in publications, background papers, market data, newsletters, etc., on the relevant topics. In Preserve, we're responsible, as Peter said, for communication, dissemination, training, standardization, and regulatory affairs. And also, we coordinate this innovation roadmap. We don't do it. We could never do that alone. Obviously, this is a group work in which we also include all key stakeholder input, because this is not only for us, this is for everyone. We also organize this annual conference, the European Bioplastics Conference in Berlin every year in December. And this year it's the 10th and 11th of December. I just invite you to go to our website. The call for papers is still open. You have a free pass with if you submit a paper. So then just take a look at our website and join. I'll talk more about December because it's quite huge for us, as Christina already said. We are finishing the project. The roadmap is being finished. We have our Preserve final event. I'll talk about that later on. So, having presented myself and European Bioplastics, let's discuss why do we need a Preserve roadmap here. As you can see, we have our project is funded by Horizon 2020, responding to a call on upcycling bioplastics of food and drinks packaging, a research and innovation call launched in 2019, actually. It was a two-stage, and in which already as our goal, of course, while answering to this call is to upcycle bioplastics in food and drink packaging. Christina already presented that. Nicola and Robert already talk all about what is a part of what we're doing. As you can see in this paragraph, so that comes from the call, right? And an expected impact of the project is a viable roadmap to prove that by 2030, 60% of the plastics still to be used for packaging of food and drinks with short shelf life will be produced from renewable sources. So therefore, we're working on it. That's why we're here. And but why ask for a roadmap, right? At all? Why? Not only to this project. This was a call. We have all the sister projects that are funded under this call, and this is a common practice actually in European funded projects, and a good, if you ask me, a good one. In our particular case, what do we bring to the table, right? What do we think that we bring to the table with this roadmap? Well, we contribute to policy alignment and integration, right? So with this roadmap, we hope to align the Preserve project goals with broader EU policies and frameworks, such as the European Green Deal and the Circular Economy Action Plan. And so our speaker from Vienna would then say all about it. He's the expert here. But we hope to contribute to that. We also hope to contribute to the promotion of innovation and best practices that can be scaled up or replicated across Europe. Right? We can identify and promote best practice, and we can also facilitate the stakeholder engagement and collaboration among various stakeholders, including EU institutions, member states, local authorities, NGOs, academia, private sector. So we hope to encourage partnerships based on shared goals and responsibilities. So in essence, for us, the roadmap is essential for guiding the Preserve project towards achieving its objectives within the EU context. That is the whole plan. So we have been working for some 6 months already in developing this roadmap, and it's a process that we kicked off last December 2023 as a co-design process in an event also in Berlin, a side event to our European Bioplastics Conference organized by CrowdHelix. They organized super events, as you can see. And there we started gathering input from key stakeholders. But before going into that, these are the elements that we would include in our roadmap at the end that will be presented in December. So we want to include the strategy outlining the steps to move from the preserved solutions based on the individual key exploitable result roadmaps. We want to also present key findings and the remaining knowledge gaps arising from the project. You'll see that today I'm going to talk a lot about that. Also about the interdependencies across the supply and value chain, and also set up recommendations contributing to the uptake of our results, right? Therefore, the main sources of our roadmap are obvious. It's obviously all the work that we're doing, the technical working packages, obviously what Cristina, Nicola, and Robert already presented, but so much more that we're doing in our work package, in technical work packages, or we have already done. Also the value chain roadmap and innovation impacts work package, that's mine, with all the colleagues. So innovation, exploitation, dissemination, communication, consumer perception. Cristina mentioned, if you had, please save the QR code so you can actually help us in this process. This is where I play my part, right? Then we have the safety, environmental, and economic sustainability assessments. We have colleagues from NTT and IPENE doing that, and advisory board input. We have a member of our advisory board speaking later, Barbara. So this is where all the input are coming, and from you, and from the event that we had where we launched our co-design process in the 11th of December. And we had here a group, we had two different elements, a panel discussion in which we brought together industry, research, academia, innovation, and policymaking, European Commission, so Total Energy Scorpion, Cradle to Cradle, you can see Alpstad, Technical University, and the European Commission. And we had then a mini workshop with all participants to our event in which we explored some questions. Then moving on, what I just mentioned before, during our Preserve event, we held this panel discussion, I already mentioned, with industry, research, innovation, academia, and policymaking. And the insights that we gathered there were invaluable and helped shape our roadmap and actually the directions on as you saw, the elements that we're going to include in this roadmap. Of course, these inputs will form one of the big parts of the roadmap, but not only, obviously, everything that we're doing in Preserve. But here we're focusing on this input, on the where we're moving, where are we going, on the gaps, challenges, opportunities, etc. So, my screen, yes. What did we discuss there? And Peter actually was the moderator of this incredible panel, and it was one of the best panels that I've lived in the last times. It was really enjoyable. We put the question to our panel: where are we moving in the field of sustainable circular packaging? What is the trend? Where are we going? And this was 6 months ago, okay? And to no surprise, material recycling and compostability was on the top of the list. And this is what we are talking about today, right? The emphasis on material recycling, industrial compostability, chemical recycling to enable circular packaging. This is where we're going, obviously. This is where we all want to go, right? Then, of course, design for sustainability, innovation in packaging materials. Because of the time, I'm not going to go through every bullet point. You will have the presentation, you will have the recording. But of course, also where we're moving in EU policy, capacity building, in the consumer education and engagement, the collaboration and system integration, this is all where we're moving, all the trends, but also already the panel identified and highlighted some gaps, some challenges, some opportunities. These were the main challenges that were identified. These are the main ones. There are more, surely, but well, this is a summary. On policy and regulation, well, again, this is one of the things that comes up as most important always, the need for a unified and rapid government policies, the necessary incentives, but also the financial constraints, the consumer awareness and education. And you, with your poll, already showed how important this is. This policy and regulation and consumer awareness and education are really top there always. But recycling infrastructure, the current recycling of bio-based packages perhaps not fully affordable or efficient. We need to work on that in the standardization and measurement. But not everything is a challenge. There are not only challenges, there are also current opportunities. Our panel also identified the government support and subsidies. So there is a lot of support as well. There is innovation scaling up, consumer engagement, increasing consumer awareness and education drives the demand for bio-based packaging. Harmonized standards and global collaboration and circular economy initiatives. These are all opportunities that are there for us to grab with the right conditions, right? The gaps. Again, these gaps were the three main gaps identified: market, regulatory, and research and innovation. And actually here, we are on it, right? But there are strategies. They also put forward strategies actually to bridge these gaps, to overcome the challenges and seize the opportunities, right? And these are potential strategies to implement on the market expansion and incentives, on regulatory harmonization, and integrate research and collaboration. So these are some of the strategies. And then we had a mini workshop that actually also went through where should research focus upon. And I wanted to do another poll question, but I think that I'm going to skip that, and we're going to go to my slides still. Here are where our mini workshop where we focused on actually where should we focus on research, scalability and recyclability, very up there. I'll move forward because we're short on time, but you will have this presentation. Also on infrastructure and policy support, consumer education, closing the recycling loop. This is very important. And then we also ask from the consumer and end point of view. So consumer and end consumer point of view, what do we need, which products? And actually the conclusion was that the brains are there, the support is there, we just need to improve things, better recycling infrastructure. I'm just mentioning the ones that are very much relevant to this event today. So you have all this information. You will have that in the presentations that will be shared in YouTube. And we will be actually organizing recycling strategies for bioplastic event the 9th of December in Berlin, and our Preserve final event the 12th of December also in Berlin. All our satellite events for the European Bioplastics Conference. So please check our website.
Thank you so much, Estella, for this amazing presentation. And a couple of keywords here: engagement, education, last but not least, collaboration. I think that's a quick summary of what you just presented. Introducing him, because I'm thrilled to introduce Werner Bosmans. He's a team leader, plastics, with the European Commission, Director General Environment. Werner joined the Directorate General Environment of the European Commission in 2005 already. He initiated the work around circular economy. In the last years, he developed the plastic strategy, the directive on single-use plastics, and the legal proposal on pallets. He is now team leader for several follow-up actions on plastics, including chemical recycling. Werner will talk about EU policies on bio-based plastics and recycling. Werner, screen is yours.
Good morning to all, and I think we can directly go to the next slides. Which I like to show to all of you, even if you know it, to put us again in why we are doing a lot of the things that we are doing. We are aiming for sustainability, and we have to be aware that several planetary boundaries are crossed. So there are multiple environmental crises. They affect us all, and we need to set up a system that can counter these crises. Next. Within Europe, you know that is about the European Green Deal, which is a climate neutral, resource efficient and competitive economy. We have the circular economy there as well. which is quite important. The definition is maintaining the value of products, materials, and resources in the economy for as long as possible. That will come back later in the presentation. We have obviously our bioeconomy strategy and its updates, where we want to scale up those bio-based sectors locally while understanding ecological boundaries. And we have as well a plastic strategy, which is mostly about improving the economics and quality of recycling, and as well curbing plastic waste and littering. This is the political framework we're working with, and I will now dive into some more specific issues. Please, next one. So I think this is the most important framework that can guide the discussion, which I will explain very shortly. It's a policy framework for bio-based, biodegradable, and compostable plastics. I will focus on the bio-based part. Next one. It is a clarifying policy framework. We all know that bioplastics are perceived as good or better for the environment. But I think we know as well that it's not because you put the word bio in front of something that it's by definition a better thing. An important issue here is the potential biomass cap. It would be about 40 to 70%. That is the gap between what the demand would be in 2050 and what could be sustainably harvested by that time within the European Union. What this policy framework says that we should not use generic claims. For instance, bioplastics. Consumers don't know what that means, bioplastics. Is it bio-based? Is it biodegradable? Is it both? This will be enforced in our proposal from that is now under discussion with Parliament and Council on empowering consumers for the green transition. We will continue to give priority to reduce, reuse, and recycle. Even if you have good material properties, we don't think that perpetuating single-use models is therefore a good solution, because that goes into our priority, which was reduce and reuse. But obviously, yes, to real sustainable alternatives. Next one, please. And bio-based plastics can be a part of the solutions. That is extremely clear, because they can help us to defossilize and to meet climate neutrality targets. You probably are aware that we have an aspirational objective of 20% of the carbon used in chemical and plastic products from sustainable non-fossil resources by 2030. That communication as well has quite a lot of discussion and how to go forward with methods to assess, monitor, and report greenhouse gas emissions and carbon removals. And very importantly, bio-based plastics can create jobs. And in fact, I should add here that it can help us to foster the strategic autonomy. Next one, please. A couple of things that we think that should happen as to make bio-based plastics work is, first of all, there needs to be a kind of specification to the biomass content. I don't think it is sufficient to say it is bio-based, while it could be between 5% and 100% of bio-based content. The ideal method is C14, but we would accept mass balance accounting as well. We want to give the priority to secondary versus primary biomass, and in this framework, I think it's very useful to remind that there's a separate collection obligation of bio-waste that is happening since the beginning of this year. We obviously want to see a cascading use of biomass, which goes very much together with our circularity ideas. And there it should go to the highest economic and environmental value added, which again is following up in the next one. We should give a priority to long-lived versus short-lived products. A very important part when we're talking about bio-based plastics is that we think they should comply with sustainability criteria. Bio-based plastics have the vocation to replace fossil fuel, so they should be better. If they're worse as fossil fuel, I mean, then it's a kind of a strange thing that we would promote them. If they are better, we need to know they are better. So there are sustainability criteria needed. And they should go along with RED 3, the Renewable Energy Directive, mainly on land use and biodiversity, but they should as well have greenhouse gas emissions counted, which is a little bit more complicated, and there's some additional research is needed, and that is ongoing at this very moment. Next one, please. I would very quickly want to say a couple of words on biodegradable and compostable plastics. This is extremely useful to reduce the plastic accumulation in the environment, soil and water, and to increase bio-waste capture. But it has very clear limits. Compared to recyclable bio-based plastics, they need to be regrown, and you need so to take into account all the environmental impacts of the resourcing, which you would not have when you have recycling. Biodegradable plastics is a system perspective. You need to have a look at the time frame and receiving environment. We think they're only suitable for specific applications, for instance, most films. And we don't think that they should there as a license to litter, which means as well that we don't think we should put up any claims on biodegradable for litter-prone products. On compostable plastics, the same. We think that recyclable is a preferred characteristic, which means that it can only go for sorry, I receive a call that I have to cancel here. Okay. Only for industrial compostable plastics that are collected, only for specific applications, for instance, bio waste bags and a few packaging applications like tea and coffee bags, sticky labels, plastic bags. Other packaging should go in material recycling. What concerns home composting, that is much closer to what you would see in the open environment, because the conditions are very different, so it goes very closely to characteristics of completely biodegradable plastics. Next one, please. Other relevant policies, next one. How did we deal with bio-based plastics in taxonomy? Taxonomy is the framework that can guide investments. It's a framework that can guide investments. It doesn't mean that other investments are not possible. These are the framework to guide sustainable investments. They should be best in class. We have two delegated acts, one on climate, one on the environment. In the Climate Delegated Act, it is focused on plastic in its primary form. We say that bio-based plastics there is a useful thing if there's a sustainable contribution to climate change mitigation. And a valid option that if biomass is compliant with bioenergy sustainability criteria, RED 3, as I already mentioned, and life cycle greenhouse gas emissions are lower than fossil-based equivalents, which is also in line with what I already mentioned before. In the Environmental Delegated Act, we focus on plastic packaging. We have a packaging legislation aside. I'll come back to that in a minute. So it has to be better than what we do in the packaging legislation as such. So it needs to have a substantial contribution to transition to the circular economy, and there we think it's a valid option when bio-waste feedstock is used. Next one, please. As I mentioned, the packaging regulation, packaging and packaging waste regulation, which is now there's a political agreement that was there, let's say, 2 months ago. You have a headline target, all packaging recyclable by 2030. It needs to be designed for recycling, separately collected, well sorted, and it needs to result in secondary materials of sufficient quality to be used again in the products as intended. So the whole focus is on recyclable. In addition to that, by 2035, you need recycling at scale. For innovative packaging, you have a 5-year delay that can be used after the first placing on the market. So it's not about innovative polymers that are already on the market today. Now, this means that there is an absolute reason to push for economies of scale. The packaging needs to be recyclable as such on the market, which is a quite big challenge for many of the smaller polymers. There are as well recycled content targets, which count for 2030, except a few compostables. Aside, the packaging legislation says as well that the EC, the European Commission, needs to review the technological development and environmental performance of bio-based plastics packaging. Based on that report, that needs to look as well to the sustainability criteria in RED 3, the EC can propose, three things. One is sustainability criteria for bio-based feedstock in plastic packaging. A second thing is to set up specific targets for this bio-based feedstock in plastic packaging. And a third one is to look at the combination of those targets with recycled content targets. This is the only legislation where bio-based materials and plastics are really put forward. The only one, it's as well logic because it's a very recent one. It's still relatively prudent, one of the main reasons being that the sustainability criteria for bio-based plastics are not completely settled, and there are still some question marks there. Can we go to the next one? Eco-design for sustainable product regulation is a new framework that was voted, and will now enter into force normally in a couple of weeks. It is a groundbreaking piece of legislation because it really meant to make sustainable products the norm in Europe and will cover most products. It's I would say, a revolution of the existing eco-design and energy labeling rules. And it will assess sustainability aspects. It can, therefore, as well look at sustainability criteria of plastics. It's not clear yet if plastics will be in the first work plan. These discussions are still ongoing. That should be clear by the end of the year. Next one, please. So how do I think that that the way forward could be done? First of all, as I said, the use of biological resources is not by default sustainable. However, they can defossilize the chemical industry and create jobs, as well plastics. Everyone who needs to work on this needs to look at the biomass gap. This needs really to be taken duly into account. The frameworks that we're having, they are evolving. We will update the EU bioeconomy strategy, and that's planned for next year. As I said, we have the packaging and packaging legislation and our eco-design. We can work there with targets. It is possible. If that will be done, that's not clear yet. It all depends on sustainability criteria that needs to be developed and used. And as I said already, RED 3 circularity and cascading principle will be enormously important. But as well, despite these kind of challenges, we do think that sustainable, recyclable, bio-based plastics are completely part of the future. And that's my last slide, so thank you.
Thank you so much, Werner, for your information and also the willingness to provide a strategy from the European Commission. And I'm so excited to hear that when I knew that you were coming on, as a speaker, like this is great because you're one of the brains behind all of what we're working on. And the thing is, for me, we're in a transition and we should not fear the transition. We should embrace the change. And we're going through the change for the sake for our futures, for our next generations, for our children, to make them being able to live on our planet, because essentially that is what we are talking about. I am going to introduce our next speaker, Barbara Chaplin, and while she is going to pull up her presentation, please join me welcoming her to us. She is a senior sustainability manager, Simpress and Preserve Horizon 2020 external advisory board member, She previously founded a zero waste startup and has more than 10 years of experience in large companies in the private sector. Barbara will talk about transitioning to bio-based plastics, understanding industry challenges. So Barbara, presentation is pulled up. Screen is yours.
Thank you very much for the introduction, Peter, and thank you everyone for the opportunity to share some views here today. A lot of great information has already been mentioned, so I will just try to add a sort of business perspective on bio-based plastic end of life. I will first mention the role of some key players because they have an important impact on companies' decisions, and then talk about what could be maybe some enablers to help the circularity of bio-based plastics, followed by recent innovations that are already in the market, further, let's say, advanced and at industrial scale, and with some maybe considerations for the future. The first entity I wanted to mention is the Ellen MacArthur Foundation. So when looking at large brands, especially in the fast-moving consumer goods sector, the FMCG, which hold a large part of the plastic packaging footprint today globally, many companies have made public voluntary commitments that were promoted by the EMF. It's a non-profit that really promotes circularity in the plastic industry, amongst other topics. And through these public commitments, brand owners' common target is to reach 100% reusable, recyclable, or compostable plastic by 2025. Therefore, a line or the target itself was, let's say, a bit advanced of what the EU target is. However, this target is most likely going to be missed. It was announced this year, but the general direction remains. So I think these voluntary commitments are really helpful in generating an increased demand for bioplastics in general, bio-based plastics. But there is a caveat to that, and is that so far brand owners have not massively turned to compostable plastic packaging, and their adoption rate on the average of the signatories of the commitment is less than 0.01%. What may explain this, and that's also very much the reason why we're here today, is that the current view of the EMF is that, and the EU Commission, is that compostable plastic should be limited to certain applications due to their end-of-life complexity. You can see in the little graphic here that although this is just a representative framework, the end of life of anaerobic digestion and/or composting is quite small compared to recycling. And aside, yes, and improving end-of-life scenarios in general is really important for bio-based plastics for their wider adoption, I believe. So aside from voluntary commitments, companies must certify the end of life, so the recyclability or compostability of their plastic packaging. And as mentioned by Werner, here's their upcoming regulations against greenwashing to protect customers, which is great. And that means that certifying end of life claims is very important for most companies. First, for recyclability certification in Europe, Recyclas has emerged as a key player. It is a cross-industry initiative that considers the real recyclers' processes to issue common industry-recognized test methods to certify the recyclability of the main plastic types. Their guidelines today focus on PE, PP, HDP, PET, and PS. Which they explain is due to the value of the recycling stream and recognition by recyclers. So unfortunately, biodegradable plastics are considered a contaminant by Recyclas. There is no, and you can see in terms of the near-infrared sorting, the process they explain what happens in their members that are recyclers, is that there's no positive sorting of, for example, PLA, and it ends up in mixed plastic waste. But studies have shown that optical sorting technology, for example, would be capable of separating PLA, which means that positive sorting at curbside, at material recovery facilities, etc., could happen with investments in sorting technology. So, provided that one of the limitations for broader applications of bio-based plastics and adoption today is the risk of contamination at curbside, maybe investing in improved sorting would be a valuable long-term approach. Then the other key end-of-life option, which is compostability. Here I'm kind of putting together home compostability and industrial compostability, but of course they have differences. But the positive trend is that the number of industrial composting facilities is expected to grow a lot in the next years. So that should really help with the volume capacity in Europe. But I would like to kind of bring up maybe some challenges with industrial composting standards today. The fact is that they are various, so they may relate to different test methods. And to the best of my knowledge, even though a bio-based plastic is approved according to certain standards, there's been studies that actually might still be rejected in reality because the real life environment of an industrial composter might not be exactly reflected in the standards today. And this kind of misalignment might be detrimental to adoption of further bio-based plastics. So, as Werner mentioned, composting is great, but recycling is better in terms of inherent value of the material and just a smaller reverse loop. So I think that what could be beneficial is maybe an aligned guidelines or test methods that are supported by the industrial composters and maybe would increase really the treatment of bio-based plastic in industrial composters. Then I would quickly mention some potential enablers for these changes, because structural changes are needed in terms of sorting, end of life, etc. for bio-based plastic. EPR could be one of them. Of course, the industry is not as big as fossil fuel, and you would hope EPR would be then very small, but help to kind of finance maybe improvements in the industry. Deposit return schemes is of course one. They are challenging to implement across Europe, but that would be ideal because then the cost of collection would be much lower than at curbside. And there's one initiative that I wanted to mention, which is the recycling partnerships. This is actually in the USA. And I don't know that the same system should be implemented in Europe, but I just think it's an interesting approach, where the recycling partnership basically gathers funds directly from companies and brand owners to finance improvements in sorting and recycling capabilities of plastic recyclers in the US in the form of grants. They focus on the traditional resins, let's say, PE, PP, etc. But I think the initiative is interesting because it's a direct improvement targeted to certain sorting capabilities of, for example, only polypropylene. So we could imagine a similar initiative in Europe focused on bioplastics. This could, for example, first allow bioplastics to be correctly sorted at curbside and avoid this risk of contamination of the traditional plastics. So if I'm thinking PLA versus PET, for example, and that would then enable a new recycling streams for these new biopolymers, which I think would be really helpful. I will now talk about some recent innovations that are a positive sign of where the industry is going. Preserve is obviously key in that, but I will just mention some projects that are already live, some entities that are already acting on this. The first one is the first, as far as I know, first chemical recycling plant for PLA by Corbion in Thailand. And what is very interesting is that because it's a direct feed into their PLA production plant there, they have vertical integration, and that's probably very efficient for their activity. And as you can see, the depolymerization of the PLA pellets happen on sites, and then that is the monomers are directly fed with lactic acid together for repolymerization. And also find interesting that they call to the industry to get in touch and set up collection structure for PLA in general. So promoting industry collaboration as well. And the other one mentioned, and that's also very much the area of preserve, but here I mention it mostly because it's already on the market and already certified by this entity, Recyclas. So is CodeThink, and I'm sure there are others, but that's one that I could find. And I think what is very positive here is where bio-based plastic have a clear advantage is in the barrier coating application, because they enable previously unrecyclable flexible pouches, for example, to become recyclable. And that's really a clear competitive advantage there. And only to mention, there's also certified mass balance approach, which was mentioned by Werner, to integrate the drop-in polymers in existing fossil-based plastic production. And although this may not be the end goal, it should help bring more volume and therefore more competitiveness in the industry, because there's maybe smaller addition rates, but increasing over time. And to conclude, these are just some considerations, not statements, but I would say that in terms of industrial composting, certifications need to reflect real composting condition for better adoption. Recycling in existing streams is of course ideal for drop-in polymers and barrier coatings. And I am not sure of the development and impact of chemical recycling, but it will be something to watch for sure and understand the role it has to play. And creating new recycling streams for biopolymers is definitely the most valuable stream when possible, but that of course requires investment in collection sorting, for sure sorting at curbside to be enabled. Thank you for your attention and for the time.
Thank you so much, Barbara, for your insightful presentation. While our next speaker, Paul McKenna, is introducing us to CrowdHelix platform and the circular plastic helix from impact acceleration and future collaboration. Paul McKenna is the head of membership operations at CrowdHelix. Paul, the floor, in this case, the screen is yours.
Thank you. So today I'll be speaking about the CrowdHelix platform and how we use it to drive impact for projects we participate in. Bianca, we can move to the next slide, please. CrowdHelix takes a leading role in delivering impact acceleration for projects. We currently partner in 35 Horizon projects, and we use our platform, our network, and our helixes to drive impact, to promote specific project activities and the key exploitable results that arise from our projects. As a very quick overview, CrowdHelix is an open innovation platform and network of over 800 members comprising sector-leading research centers, universities, and businesses dedicated to collaboration, impact, education, and open innovation. We currently have over 15,445 individual users profiled on the platform across 75 countries, and to date, our members have collectively secured 11.79 billion in Horizon project funding. Next slide, please, Bianca. The CrowdHelix platform is structured around Helix communities. A Helix is a thematic virtual community populated by users on the platform and a place for building consortia, developing networks, and delivering impact. We currently have 53 Helix communities on the platform, each with its own thematic research area of focus and community of interested stakeholders. A number of the Helix communities on the platform have been specifically curated to deliver impact for a Horizon project on which Crowd Helix is a partner delivering in an impact acceleration role. You can see an example of 48 of the helixes, of the 53 helixes on the screen there. Next slide, please, Bianca. So the Circular Plastics Helix is a specific virtual thematic community of experts with a particular interest in the plastics, circular economy and recycling on which the Preserve project is featured. The Helix was originally created for the multi-cycle project, which passed on the baton to Preserve when it ended. Preserve benefited from this by having an already built and established community for the project on the Crowd Helix platform to showcase the project, its activities and results. Members can profile their organisation and logos on Helix to raise visibility and awareness that they are a key player in that thematic space. And you can possibly see some of the logos, organisational logos featured on the screen grab of the landing page of the Circular Plastic Helix towards the bottom right-hand corner of the slide there. All project partners have been invited to join the platform and community for the lifetime of the project. The Circular Plastics Helix is open for anyone to see it, and it has a growing community of 772 researchers from 261 organisations spanning 49 countries. So quite a significant reach on the Helix. The organisational membership of the Helix comprises 163 RTOs and universities, 70 SMEs, 14 corporations, and 14 networks and associations. Additionally, we have 7,646 interested users who are notified about the activity in the Helix through daily or weekly digest emails because they've chosen to subscribe to the Circular Plastic Helix community and receive notifications on posts made in that particular community. To date, we have had 111 posts on the Circular Plastics Helix, and there are 3 areas in each Helix community: opportunities, results, and events. This, next slide, please. Thanks, Bianca. This slide shows examples of opportunity-related posts that would be featured on a Helix community. The most typical posts are from researchers seeking collaborators for upcoming funding opportunities, typically Horizon calls, but not limited to, as demonstrated by the post in the middle of the slide. We can also post on the Helix to notify the community of training events, opportunities, and other types of interactions, such as seeking participation with consumer perception surveys, etc., as the other 2 posts on this slide show. You can see the Preserve logo featured on the posts on the left and the right-hand side because these are specifically related to the Preserve project, and this feature enables us to showcase Preserve on the specific project-related posts. Next slide, please, Bianca. The next slide shows posts that have been made in the results area of the Circular Plastics Helix community. This area is a great way for stakeholders to showcase their key exploitable results, driving impact and visibility of the research and innovation activities that they have been conducting. There have been 8 results posted on the results section of the Circular Plastics Helix to date, 3 of which are specific to Preserve. Again, you'll notice on the posts on the left-hand side, the Preserve logo featured on those results, since these are specific Preserve-related results. You may also see the varying TRL levels that the results have been posted on across the results area, which is another feature on the results side. So just in quick summary, the Helix communities can be used in the pre-award space to build consortia for research projects, to drive impact and awareness for existing projects by promoting training opportunities arising from the projects, seeking participation in surveys for projects, as well as promoting key exploitable results arising from projects in the post-award area of the value chain, as well as promotion of specific related events as well. The posts on the Crowd Helix platform can be posted across up to 3 communities. Typically, posts in the Circular Plastics community will also be posted in the circular industry, materials and manufacturing helixes, each with their own community of stakeholders, which significantly increases the reach and visibility of the posts across the Crowd Helix platform and our community. We welcome and encourage our members to actively engage with and participate in posting on the platform, and in particular the circular plastics community, which we feature the Preserve project on. Thank you very much, and that's my presentation.
Thank you so much, Paul McKenna. It's amazing to finish this this session with you. You know, I think with the Crowd Helix, you're showing what is needed, collaboration. You have a platform to do that, a community that allows collaboration, talking about collaboration and engagement. Would like to ask our team, event team, are there maybe one or two questions from the audience that we could still take?
Hi, Peter. Thank you very
Yes.
much for all your input today and everyone's input. The event has been amazing. We did have quite a few questions, but our speakers have answered to the majority of them. We could, if you want to, we could address one just for the recording and just in case other people
I
might.
think one. Looking at the time, we have room for one question.
Perfect.
So what would be the question and who can we ask the question to?
So I do have a question. I think it's quite good. It says in the multi-layer processes of metallized, sorry, I'm not a scientist, so I'm going to try my best. Metallized PLA, is it possible to effectively separate so that the PLA is biodegradable or compostable, or is it the PLA, or rather the multi-layer, just recycled? And I think that would go either to Robbie or Nicolo, if I'm correct.
Robbie or Nicolo, would you be able to take this question?
Oh, we have Nicolo.
Nicolo is there, yes.
The PLA is biodegradable in industrial conditions. So you have the temperature is near to 60 degrees, and the humidity of the air is controlled. And I think the PLA is possible to recycle because the mechanical property of this material after the delamination is similar to the material before. So I think it's possible to recycling the PLA.
Thank you, Nicolo. And we do have one more question that I can see has been unanswered in the chat. So I think it's good to.
Oh yeah, do it. Take it. Yeah, please go ahead. Yeah.
Perfect. Thank you. So we have is there any information on effective segregation / separation processes of PLA from other polyesters, I think it's called, sorry.
Polyesters,
Example,
yeah, from other
NRI techniques.
To the best of my knowledge, it is possible to differentiate PLA versus PET. But of course, with multi-layers or NIR technique, it's not as simple, but it is possible. The signal you get will be different. So ideally, it should be possible to be implemented.
Well, that's good to know that it is feasible, that we think. So one of the things that we learned about today, for me, like a quick summary of our event, it was amazing to get the introduction about Preserve. We talk about Preserve, but you want to know what we actually do. Thank you for the introduction, Christina, there. But also we discussed the delamination and how the separation actually is done, where we also heard more about microfibrillated technologies and how enzymes is used in PLA to enhance mechanical processing. Then we heard more about the 2030 roadmap, where we were engaging with you through several engagement polls. Then our EU policies that were shared, the strategy by the European Commission on bio-based materials. I thought that was helpful. And also showed me that, hey, there is still room for collaboration. There's room for you to jump on our train together. Not only our train, it's a train of everyone that lives on the planet, essentially. But then, with that said, we do go through challenges. And that was actually presented in the last presentation. Then we also had Crowd Helix sharing their platform of collaboration and and what we do and what you can do to contribute, how that community crowd Hillis could help you to work with us. But to close off today, to learn more, visit our Preserve Horizon 2020 website. And of course, last but not least, a big thanks to our audience today, to you. We always love hanging out with you and appreciate the time that you have spent with us today in our webinar. Thank you all for joining, and we hope to see you again very soon. And until then, thank you very much. And do not forget to check out our website, www.preserve-h2020.eu, and follow us on LinkedIn for the latest and greatest Preserve news. Take care and have a great day.